backyard chilling a little bit, and we wanted to, it's supposed to get good and hot today, guys, and I just wanted to make sure that the American Standard heat pump was up to par here. So basically what we're going to do, guys, we're going to take a little peek at it utilizing our Testo 550 there, which I think is one of the best digital manifolds on the market today. I love the Testo lineup, whatever it is, the 320 I got and the 435 I'm getting ready to get. But anyway, I know a lot of y'all guys have went out and got the Testo 550s or the Testo 557s or the Testo 570s, which I think are all fantastic. Even some of the different manufacturers out there have great digital meters. To me, like I said, the compound, I would never go back to compound. I could set out a compound gauge and I could have 5 of us look at it, and I guarantee all 5 of us would probably come up with a different measurement. But anyway, nonetheless, basically what I wanted to do was maybe cover some of the functionality on it. And like I said, you know, you can run your Testo 550, Testo 557, Testo 570. If I do upgrade, it's going to be to the 570 just for the simple fact that I want printing capability on everything that I have. I wish they could actually come out with a Testo 550 that it would actually print, and I'm pretty daggone sure they probably could. I bet they could. They got my Testo 320 lined out real quick, so I'm hoping maybe somebody over at Testo might actually see this and maybe customize my Testo 550 for me and put me a little IR in there. But anyway, guys, I'm just kidding. But it would be cool if y'all could do that. Like I said, I don't need the bells and whistles of the other ones with the micron stuff all on it, man. I'm just not into that. I've actually, you know, I've got my vacuum lined out the way I want it to be. I run straight vacuum with a micron gauge. I don't even put a manifold into the mix. There's no point in it. That's another potential leak right there. But anyway, guys, that being said, let's get after brass tacks here. So basically what we're doing here, guys, is we're out here to my American Standard Heritage 13 SEER 2.5 ton R22 unit, and it's a TXV unit. And basically what we're looking here for, guys, is what we're looking at right here is our 10 degrees Fahrenheit design subcooling. And basically, guys, this is what the manufacturers actually came up with, the engineers that actually made the equipment here. This is what's going to get us a solid column at 10 degrees subcooling, should be delivering us a solid column of liquid to our TXV, okay? And that being said, the point with that, okay, that is fantastic. You know, you definitely want to dial into your 10 degrees subcooling or whatever your piece of equipment's actually asking you to dial into. That's what you want to get. But we can't just say, okay, man, I got my 10, let's pack the tools up, get in the truck, let's go. No, guys, there's, like I said on a few videos back on a tech tip video, we need to be looking at both sides of the systems, guys. And you know, what we're actually going to do here today is I'm going to show you the Superheat out here, and then I'm actually going to take you into the house, and we're going to take a peek at it at the evaporator also. So I reckon this is what they call, I'm not sure, I'm not Mr. Super Tech, so if I get some of my terminology wrong, please bear with me. I guess this is going to be called total system superheat or compressor superheat. You know, we're right here at the end of it right here, and what we've got is we've got our appropriate hoses, and I got me a label maker, guys, and I've got R22 hoses and I've got R410A hoses. That way I don't get them mixed up. And I've got my hoses hooked to the appropriate ports. I've got my temperature probes hooked to the appropriate ports. Okay. All right. So for the functionality of the Testo here. What we're looking at here, right here, guys, on this bottom number on the left. Now the numbers may be different, but the bottom number on the left is always going to be your suction pressure, okay? Your suction pressure, bottom number on the left. Bottom number on the right is always going to be your liquid pressure. It is always going to be your liquid pressure, okay? All right, here's your suction pressure immediately above it where it says T1 right there. That is going to be your suction line temperature, and that's what we're getting off of our probes down there. The one on top of suction line pressure is always going to be your suction line temperature, and you can see it indicated in Fahrenheit T1. Okay, now we're going to come right over here. Your liquid line here. Above it, that is always going to be your liquid line temperature. It's always going to be your liquid line temperature. Okay. When you rifle through most of these modes, the suction line temperature, the suction line pressure, and the liquid line pressure is going to remain. These numbers up here are going to change. Now, there's a couple of functions on here where you lose all the numbers. But anyway, let's go ahead and get started here, guys. Let's rifle through. As we know right now, it's telling us it fit at 62.8 psig or pressure. We have 56.5 degrees Fahrenheit. At 182 pounds of pressure there, we got 86. Okay guys, so let's rifle on through the modes here. Okay, this is what can be a little bit of, can cause a little bit of confusion. And this right here, like I said, what we're actually looking at here, guys, is we're looking at total system superheat. You know, we've got our gauges hooked to the suction line port right there, and we've got our temperature probe hooked to our suction line port. And if you know old school ways with your compound gauge, you would actually get your suction line pressure to do superheat. You'd actually get your suction line pressure, you'd actually get your suction line temperature, and then you'd look at your compound gauge, and whether it be 22 or 410, you're going to try to determine what your saturation temperature is, guys, okay? And on that, you know, like say on the R22, you look at that little green dial and look at the pressure right where your pressure's at on it, and then follow it down, and that's going to give you your saturation. So then what you're going to actually do is you're going to take your suction line temperature minus your saturation, and that's going to tell you actually what your superheat is at the time. Now, you know, there's other instrumentation like we have right here. My PRH2 here. Hope we ain't out of batteries here. Which we have our PRH2 here, guys, and this will actually help us get our wet bulb and our dry bulb and actually come in with our, you know, and then we can plug it in and we can actually come up with another instrument. I actually use my HVAC guide, and we can actually plug that in and get the target superheat, and then we try to dial it into that. But nonetheless, guys, all right, let's get back to this here. Okay, so we're at 62.8 psig, and what we have here is 36. It's telling us that our EV is 36. Our evaporator coil is 36 degrees Fahrenheit, okay? All right, guys, a lot of us were thinking that maybe that 36 actually meant that was 36 degrees of cold air coming out, okay? That's actually in your coil. That 36 is actually in correlation with that pressure right there. That is actually your saturation temperature. Okay, guys? Let's prove it. Of course, you know, they probably don't have a 62 on here. I think it's, so what I've got out here, I've got my pressure temperature chart out here. And right here in this column here is R22, and this is pressure. So, of course, we're looking for 62.8, and it's saying it's like 36. All right, so let's come over here to 62. All right. Now, it goes from 62 directly to 64, but at 62 it's telling us it should be 35 degrees, and at 64 it's telling us it should be 35 degrees, or excuse me, at 62 it's telling us it should be 35 degrees, and at 64 it's telling us it should be 37. So 63 would be in between that, and I would assume that 63 would be 36, and we're right there at 36. We're at 62.9, and we're right there at 36, okay? And of course, like I said, it's fluctuating. We got a TXV on here. So I think that's pretty much telling us that's what that EV means. That is actually our saturation temperature for that pressure given at hand. All right, let's try to prove this again. Excuse me, guys. My allergies are getting to me. All right, at 182, it's telling us that the condenser temperature, or the condenser temperature, you know, and that's what I would assume, CO, right there at the bottom, our condenser temperature is 95.4. Well, like I said, it's actually our saturation temperature, and let's come over here and prove it. We're at 183.2, and it's telling us 95. All right, and of course there probably ain't a 183 on here. Okay, we've got a 180, and we've got 90. At 180 it's 94, and at 185 it's 96. Okay, so we're at 184 and it's saying 95.9. So this is dead in the ballpark, guys. So actually what these temperature readings are that we're seeing right here, the EV and the CO, the evaporator temperature and the condenser temperature, are actually the saturation temperatures. And we're actually going to prove that, guys. I've actually got my Testo 320 hooked up downstairs. We're going to do a split. I've actually got my my fill piece hooked up down there with my temperature clamp, and I've actually got a compound gauge, one of those little compound gauges like you know, some of the fellas use on here, and I've actually got that hooked up to my coil. My American standard coil actually comes with a port on it. So we're actually going to prove a point. We're going to show it exactly what evaporator superheat is, and right now what we're seeing is total system superheat. So let's go ahead and see if Fritz is dialed in. Let's see what our superheat is, and see what. Uh-oh. Oops, sorry guys. So yeah, still on a learning curve. All right, so what we're looking at now is the EV 36 and our CO 95 or 96. All right, let's rifle through here a little bit. Okay guys, here was another good one here. All right, you see where it says 29 and you're seeing the delta T symbol, or 30, you know, like I said, it's fluctuating. I also thought the same thing too, guys, that how in the heck is that telling me what my split is? You know how we usually do our split downstairs or up in the attic or whatnot. You know how we go from our return and you know, when we get our supply and our return split there, but our delta T. But actually, guys, if you look at that, it's 30.3, right? So let's come back. If you look here, the temperature, like I said, right above the liquid line is 86.2, fluctuating a little bit, 86. Let's just call it 86, and our liquid, our suction temperature here is 55. Let's just call it 56. All right, so 86 minus 56. Okay, that's actually what this is, guys. Now, I mean, it's, you know, like I said, the numbers are changing in there. They're fluctuating, but not off by far. But give or take, that's what that delta T is right there. The delta T on the Testo 550 is the actual temperature differential on the probes you have on here. It's the temperature differential in between T1 and T2. Your suction line temperature and your liquid line temperature. Okay, guys? All right, well, let's go ahead and see if Fritz is dialed in here. We're looking for what, 10 degrees subcool? All right, guys, plus or minus 3. Looks like Rochester's heating and air there is running at 9.3, and it's going to fluctuate a little bit. I'd say it's going to come up, probably hit 10.1, 10.2. And our superheat, guys, it looks like we're running at 20.5. I think these are some fantastic numbers, guys. I truly do. But anyway, like I said, it's starting to heat up here pretty good. I think we're running at right around 87 degrees now. 55% relative humidity. So anyway, let me go ahead and write these pressures down real quick, guys. Just bear with me here. So what I've got here, I'm going to write down my suction pressure, my suction temperature, my saturation temperature, yada yada yada. All right, so on the suction pressure, we got 62.7. Like I said, it's going to fluctuate. Let's see. I'm going to just call it 62.7. Okay, and our superheat is 20.3. Our suction temperature, well, let me go ahead and get our liquid pressure first. All right, liquid pressure is 184.2. Our subcooling is 10.1. Okay, let's get our temperature. Our T1, like I said, T1 is always your suction line temperature. That's 56.5. Okay, T2 is our liquid line temperature. That's 86.2. Okay, and let's go ahead and get our saturation temperatures. Our suction line saturation temperature is 36. And our liquid line saturation temperature is 96.4. 96.6. We're just going to call it 96.4, guys. And it is what? Okay. Okay, guys, let's take a little trip down in the basement and show you what I got set up down there. Go ahead and take our saturation temperature chart with us. Sporling. All right, guys, let's go see what we got. And like I said, I've got a compound gauge hooked to it down there. Come on, boy, it's hot. Come on. Okay, guys, let's come on in here and take a peek. Come on, boy. It's cooler down here. Get you some water. Come on. You wanna go? Okay. All right, guys. Now what I've done here is I've actually got my Testo 320 hooked up. I've got my fill piece hooked up. So, and I've got my new compound gauge Eddie hooked me up with. So what we're going to do is we're going to pull this dude to temperature. I think I may be upgrading my meter here shortly. Alright, looks like we're running at 51 degrees down here at the evaporator coil. And like I said, by far, no means my system. I've actually, I've just now got a load calc program I've had for maybe a year or two now. And when I put my new system in, my Ameristar down here by American Standard, I put in an 80,000 BTU furnace, and actually I took out a 110,000 BTU furnace out of here, and I figured 80,000 would be adequate. Okay, but once I got my load calc program and I did my load calc, I came up with I only need, it's still oversized, I only need like 60,000 BTUs down here. But anyway, nonetheless, all right, let's get back to what we were doing. What I've done here is I've got my Testo set up also, and what we're actually doing here is we're getting our true Delta T. Now this is the Delta T that we're looking for here, guys. So what I do is I have T1, which is my probe that has the wand on it. I have it right down here in my return, about center of it. And right here we have T2, and I have that about center here, and I'm out of direct fire of the coil. Okay, I'm about 12 inches away, give or take a few. And like I said, we've got the fill piece set here to temperature, and I've got my compound gauge on here also. And to get the saturation temperature, like we were talking outside, we need to be this is an R22 system, so we're not looking for that pink or whatever, rose color or whatever that is. That's the 410. We're actually looking for that green right there, the R22, just the same color as your jug. And basically, this is what I love about the Testo, guys. It looks like I'm basically in between. I think it's in increments of 10. So right there from 0, we'd have 10. 20, 30, 40, that center one right there with the white dot would be 50, and just so happens nothing can ever be dead on. It looks like we have 50, 60, and 70, so it looks like we're in between the 60 and the 70 hash mark right there. So I'd say we're probably at about 68. Now if you look at the green right there, it's saying we're a little bit over 30. Okay, but that's where the pressure temperature chart comes into play again, guys. So what we're actually going to do is it's showing us we're pretty daggone close to 70. So let's see what 70 is on here. Okay, guys, 70, we should be running at 41. 70 at 41, okay? Now, I think we're just a little bit below that. I think we're actually running like it's 68 or 69 PSIG. So let's see what that is. 68 is saying 40, okay? 68 is saying 40. And I'm pretty sure that's about where we should be at, okay? So basically what we would do there, guys, is we'd do it longhand. We'd take our 50 degrees here, and we'd take our saturation temperature right there, and we'd minus it. And basically what were we saying? We had like approximately, it's in between 60 and 70. So I'm not sure what that is. You know, it could be 60, you know, 65, 66, you know what I'm saying? I'm not positive what that is. All right, but you know, I guess we can get in the ballpark. So like I said, at 65 or 64 it should be 37, at 66 it should be 38. At 68, it should be 40. Okay, so like I said, what you basically do is you take, let's say for instance, it was at the 40. Okay, so what we'd do to get our actual evaporator superheat temperature, we would minus that 50 right there by whatever our saturation temperature we actually, you know, could actually tell what it was on the gauge here, and that would actually, let's say it was the 41. Let's say we were at 68 PSIG there. And the 41, so we take 50 minus 40, and that would give us our superheat, our actual evaporator superheat. But what I want to do, guys, is I want to take it up to the next level. If y'all will just bear with me a minute, I'm going to run out there and grab the Testos, and we're going to hook the Testos to it and eliminate this compound gauge here, guys. But Eddie's got another way of doing this too, he actually doesn't even really hook his gauge up. He's actually got like one of those Testo fast thermometers or whatever, and he'll actually get his return air temperature here, and I believe he minuses it by 35, and then takes the temperature off the suction line, and then he comes up with his superheat in that form. I believe that's how he does it. Man, I think that'd make a great video of him showing how to do that actually. But anyway, guys, this is the way I do it, and like I said, there's probably different other ways. But as soon as I can afford that 435, guys, I am taking this to the next level. I'm going to eliminate every bit of this. I'm going to do like Eddie did over here when he tested my stuff. I'm going to drill my 3 holes, which are right behind this. And I'm going to drill my 3 holes, and I'm going to plug my 435 in there, guys, and I'm going to be rocking it. I'm going to be printing it out, and I'm going to know exactly what the system's doing. But right now, just with a few tools, you know, we can determine what's going on. So here I am running on again. Let me go out there and get the Testos, and we'll get them hooked up, and we'll actually see what they look like on here. All right, guys, thanks so much for watching.